Hello everyone, and welcome to another episode of ARM through C, where we learn the assembly language by decompiling C code. This time we're going to look at branching. We've already seen an instance of branching in our last example about assignments, where we had an unconditional branch that caused a while loop to repeat itself. But this time we're going to look at some more general cases linked to if statements in C, and we'll see how conditional branching works. Have fun! I have already prepared and run a little program that will show us the basics of branching in assembly. What we have here are three if statements that compare two variables A and B and assign the variable C a certain result. C is just a dummy variable, just to complete the example. And the three variables, A, B, and C, have different types. A and C are integer 8 bits wide, and variable B is 16 bits wide. And I've done this for a reason. In my previous example about assignments, I used to refer to various instructions like move and store with just that name. But in reality, there are different variations of those instructions depending on what we are trying to achieve and what is the width of the data. For example, the instruction that we used for moving data was not move, but it was move S. And the loading instruction was not LDR, but it was, for example, LDRH. And now we're going to see what those S's and H's and other variants are. I'm sorry, but I'll skip again the first three commands of the main function that do some memory bookkeeping. I will explain what those do in a later video about functions. And I'll jump right into the move instruction, or more precisely, the move S instruction that puts the immediate value 10 into register R3, but it does more than that. And that more than that is crucial for branching. Whenever there's an S behind the name of the instruction, it means that that instruction does some other stuff besides from what its main job. So you could say that move S means move and stuff. Well, the S actually means set condition flags. And what could those condition flags be, you might ask? Well, to answer that, we have to introduce another register. And that register is called the Application Program Status Register, or APSR for short. It's a 30-bit long register, but we'll be interested only in the first 4 bits. Based on the result of the operation will thus also set the following 4 bits of the APSR register. The first most significant bit is the negative result. So if the result is negative, this bit will be set to 1. Then there's the 0 result, which means this bit will be set to 1 if the result of the operation is 0. The C and V bits carry an overflow. Both have to do with overflows for signed or unsigned operations, but we'll see that later on when we'll actually do the branching, because otherwise I will entangle myself totally in this explanation. Let's jump back into our example. So I won't explain again how data is shuffled back from memory into register. I would just like to explain what the B and the H suffixes are for the commands that use them. Those are luckily easier to explain than the APSR register. The B and H just refer to the width of the data, because our integer a is only bits wide. So we use the byte version of the store. And the B variable is 16-bit wide. So we use the H, the half-word version of the command. And the reason for this is simply it saves space in memory, in flash. This is how the ARM instruction set saves space, because if the data is short enough, it will cram it into one 32-bit instruction, and it will use a wider range only if needed. And that's all. And let's now jump into the meat of the branching. There was a pun in there. So the compare instruction is just a subtraction instruction, a sub S, that doesn't care about the actual results. It only updates the APSR register. And for subtraction, if the first argument is larger than the second one, so if we get a result larger than 0, then it will just set the carry flag to 1. And if it will be smaller, then the carry flag will be 0. So in our case, the branch if carry set will jump to the 1F2 instruction. It will jump over the C equals to 1 assignment, because our R2 register contains 400, so A is smaller than B, and it will not go into the first C equals 1 assignment. And that's our first branch. To be even more precise, the BLS will branch if C equals 0 or the 0 flag equals 1. In our case, the 0 does not equal 1 because the result of the compare was 390. And also C will not be 0 because we didn't need to borrow. And if we do not borrow, that means that C equals 1. That is just the fact of the subtraction operation. And the N, there's an N after the BLS. This just refers to the size of the jump. This jump means that it will not jump more than 2 kilobytes of difference between the addresses. It's a local jump, and the reason is, again, memory saving. It fits into one instruction, and so it uses the smaller version. And we've arrived to our last guest, which is the BNE branch, which means branch if not equal. And this branch corresponds to the E equals 1, A equals B assignment. So this will branch, as the name describes, if A and B are not equal, and they are not, so it will overshoot our assignment and it will not do it. Now we can try and guess what the branch not equal, which flag does it use. The branch not equal instruction uses the 0 flag. So if R2 and R3 were equal, the result would be 0 and the 0 flag would be set. But since it's not, this means they're not equal, and it will not jump into the assignment. And we can actually see here the APSR register, which here is in Cube IDE is denoted as XPSR, and it is a combination of various registers, but the top 4 bits are the ones that we're interested in, so the negative, 0, carry, and overflow. And since it's not 0 padded, this does not show the 0 bit, which is the first one, which means that it's actually set to 0. If it's set to 0, it means that the result was not 0. There we go. That was an elegant conclusion to this example. That is all that I wanted to say about branching. As you can see, there's a lot of other instructions that cause branching. We've only seen 3, but the idea is the same. The branching occurs based on some status, on some flag status in the APSR register. Wait, don't go just yet. I have to announce what will be the next episode. I'll probably do functions, so function calls, and finally explain the stacks stuff, or maybe switch case statements. I'm not sure. I have to learn it to a certain point before I do a video, because I'm doing this stuff as I go along. Take care, and see you next time. See you next time, really.